I'm already present mode.
I don't know how to use a surface.
It's on itch.
Go to the three dots.
It's also not the end of the world. That's Chrome though. That's like my Chrome setting.
Oh, really? So it's on his page, so you're just right or something?
Yeah. Okay.
Scroll your mouse over.
Yeah.
It's hidden.
Yeah. Okay. Thank you.
But if you need to make it bigger,
That's like my help notes. I know.
they show up here. But the font is small, so hit it twice, like hit it twice, yeah.
Ah, there you go.
I was gonna say I figured it out, but I didn't figure it out. But I got it working.
Alright, go find one of those.
Hello, everybody. It's a lot of people. Awesome.
Hi.
Hello. So I'm going to give a talk about procedural generation in terms of kind of an action arcade game and kind of how we went about doing it. A little intro about myself. My name is Michael Flood. I'm currently a Unity engineer at DOTS in Manhattan. And then that we work on some mobile puzzle games called DOTS. And then I'm also co-founder, gameplay designer, and programmer at Contigo Games. And we work on a game called StarCrossed, which we are going to be focusing on today. So what is StarCrossed? StarCrossed is a cooperative take on an action arcade space shooter. And I actually have a quick trailer we're going to try to play. I already had it open, but yeah, let's open it again. So just to give an idea of kind of what the game is that we're going to be talking about. Yay, there's music. So it's a it's 5 characters, but it's a 2-player cooperative game where the goal is you need to work together to take out the enemies. The entire game is designed around co-op where you need to be in constant communication with your partner to make sure that you know you're going after the right targets. And the entire aesthetic of the game is magical girls. So everything is pink, sparkly, and purple. So this is the game I'm going to be talking about today. And so in making this game, we needed to make sure that it was good. Oh no. Struggling. There we go, I'm back. That's cool, that ends the whole view for me. I like that. Cool. So in creating this game, we have a story mode, but we also have an endless arcade mode, and we need those enemies to scale up with difficulty in a way that is still fun and challenging for the player. It's kind of tends to be a normal design problem with games like this. So a quick disclaimer. There are many ways to handle procedural generation. This is just kind of the way we went about it for StarCrossed. I don't consider myself a procedural generation expert, just want to kind of share what we ended up doing. And the talk is going to be design focused. I have a small bit where I talk about Unity specific things, but I'm not diving into code, I'm not diving into much tech talk at all. And before working on this game, I started reading Procedural Generation and Game Design. It was edited by Tanya Short and Taryn Adams. I recommend checking out this book if you're working on a game that you may think you need procedural generation. In fact, the whole first chapter is about maybe don't use procedural generation. It's kind of a good point there where a lot of people jump to procedural generation as a way to save time and like time and energy, and if you're running a company, you're saving money. But in reality, you end up tweaking your system forever and trying to balance it forever, and you spend way longer working on procedural generation than if you were to just hand make everything. So I definitely recommend reading this if you think your game needs procedural generation. So, like I said, we have an arcade mode as well as a story mode. So for the endless arcade mode, we want to keep the game replayable. If you come back again, we want to make sure it's a little different each time. We want to make sure it kind of adapts to the way you're playing it a little bit and get harder. So if you become better at the game, you still have challenges when you come back. And so let me back up. So when we first prototyped this game and we started taking it to conventions and playtesting, we started off by just saying, okay, we have one enemy on the screen. 30 seconds later, let's put this many enemies on the screen. 30 seconds after that, more enemies. And so we were demoing the game with basically a time limit on how far you can get, because there was a certain time where there's going to be too many enemies on the screen. I think at that time, because it was a quick demo for a convention, I think the time was like 3 minutes. It was 3 minutes until you were just overwhelmed by enemies, nothing you could do about it. That's just how the game was. And I think it's like, clearly that's not a great game design, but I think it's great we started that way, because when kind of coming up with the system, I pulled that apart and looked at what was going wrong there. It's pretty obvious what was wrong, but like knowing the solution took a little bit of time. And so the first kind of thing we did was, well, we have these enemies. To scale up the enemies, we need different types of enemies, obviously. So we want to make sure this is the same enemy, but with slightly different maneuvers. So we want to have variables in what the enemies can do on the screen. That way we have a bit more to work with. More variables, the better for a system like this. You want to scale up. So here's the same enemy. This first one is just shooting bullets up, down, left, right. The second one is doing more of a radius. The third one is doing a burst shot where it's doing a radius 3 times. You can also see the third one's escaping really fast because its move speed is actually a lot higher than the other ones. It'll move around the screen a lot faster. So, but not just behaviors, we also want stats on our enemies. This creates, like I said, more variables to work with. Basically, instead of spawning just more enemies on the screen, that's not sustainable. We want the same enemies to do maybe slightly different things or behave slightly differently. That way, you're not just overwhelming the player with what they're familiar with and a lot of it. We want the enemies to get more challenging over time. And so, like, I think these are actual numbers that I pulled from the game. Attack rate is confusing because lower is actually faster in the shot. But everything else, so you can see we have health increasing on the enemies, attack rate is increasing, the speed at which the bullets move on the screen has a range, and their movement speed changes. And you can do other fun things with this, like if you notice the first version to the second version, it goes from 1 to 5, then 3 to 8. But in the third version, it goes back down to 5 because that enemy's behaviors are inherently harder. So maybe you don't always need to keep pushing the stats up. It's a mix of what that enemy does. Ranges, that's super important for what we're going to do. You want to have your stats to have like a minimum and a maximum, and then you can work from there. The next thing is you need to kind of gauge how hard an enemy is. And so this is kind of loose. You can kind of move these back and forth as you're balancing your game. You don't have to have like a concrete science to it. But hey, simple enemy is 1. This one's a little harder, put at 6. That one's really annoying when it pops up on screen. People tend to be afraid of it when they see it. We'll put that at 10. So now, when you know how much an enemy costs, when you put it on the screen, you need to figure out, well, if I'm spawning 3 enemies, what's my budget for that? If an enemy costs 1, then 6, then 10, how many total enemies should I put on the screen? And so we create a budget for that wave. So the game is wave-based. You're always going to get hit with a wave of enemies when you deal with that wave. Or if you don't take care of the wave, maybe they'll run away and a new wave will pop up. So working in waves makes it a lot easier to kind of process this. So if you have a budget of 18, you're able to say, okay, let's throw in this person. Okay, that costs 6. This next person also costs 6. And then this last one costs 1. Okay, so that wasn't our whole budget. That was 13. That was 13 of our 18. But now we have a little extra change to work with, where we can go back at each of those enemies and level them up a little bit. So once we know, okay, we're gonna put 3 enemies on the screen, but it's supposed to be a little harder than just those 3 enemies. Well, we don't want more enemies, but we want them to be harder. So we spend a little money making this one plus attack speed, that one maybe gets plus move speed, and the last one gets, because there's a lower cost enemy, we have a little more to work with, we'll give that one a bigger attack rate boost and a move speed boost. So an important thing here is we create a budget for our wave, but then we have an average cost for each enemy in the wave. And this allows us to tweak the wave of whether it's going to be a bombardment of weak enemies or maybe only a couple really strong enemies. So that number is actually very powerful to tweak. And yeah, that allows us to control like whether you get, I don't know, like 50 of those ones on the right that just kind of float around, or you get maybe a couple of the ones on the left. If you max out an enemy, for instance, so if I say the average cost of an enemy for this wave is 23, this enemy only costs 1, and the amount, if I max out all of its stats, the max possible I can spend on this enemy is only 14. So if I max it out, make another enemy. We've reached the cap of that enemy, you can take that budget and move it over to a new enemy. And scale your budget. Don't scale by time. It's kind of what I said at the beginning. If you scale by time, you're inherently kind of putting a time limit on the game. Also, by doing that, what was it? If players are killing enemies faster, then they're going to get more waves of easy enemies. And if players are killing enemies slower, they're going to get harder enemies faster, which is interesting. You don't want that. That's like the opposite of what you want, which is why you don't want to do time. You actually want to flip that. If players are struggling, you don't want to like have the next wave be super strong. You want to ramp it up with them. So incrementing that number should not be time-based. It should be an event in the game. Maybe it's each wave, maybe it's each story beat, maybe you increment it when you beat a boss, like a big gameplay event, that goes up a bit. And then, yeah, you can kind of use that number to calculate your wave cost. Another great thing is like, you don't have to make that a formula. You can have that cost maybe like, oh, you have a boss approaching and you want the enemies to ramp up to this boss and get really hard leading up to the boss, but then after the boss, you want to give your player a break. So then at that story moment, you just take that number and knock it down. And then because your entire system is kind of reliant on only a few numbers, it's easy to make that jump back and forth. When you rely on a whole formula, you have to make sure that formula works for your whole game. And that's like not sustainable because sometimes you want calm moments in your game. Sometimes you want fast moments. It's not always a steady ramp up. Also by having it controlled by one number, it allows for testing very easily. You can say, I don't know, what does my game look like at wave 150? Put in 150. Oh wow, that's not good. And you can dial it back. It's amazing for testing. Being able to jump to different parts of the difficulty curve is great. We do it with builds all the time. We're just like, let's try to build it at 100, see what happens. Another small number you can tweak to is controlling the wave timings. So you don't always want a wave to end and then there's like a little break and then a new wave happens. That's not really good. You kind of see the seams of the system if you do that. So by controlling how long the wave is, you can give it another number, which is like the wave overlap. So maybe it's like, okay, this wave is 5 seconds, and the next wave should have an overlap of 3. That means start the next one 3 seconds before the last one ends. And that allows enemies to start spawning in while the players are finishing up the wave before it, and it kind of ties it all together. And then if they are not completing the first wave, you'll see them escaping. Well, at least in StarCrossed. Sorry, I'm talking a little specifically about StarCrossed. You'll see them escaping while they're dealing with the second enemies, which creates this seamless enemies entering and leaving the screen, rather than there being a big break in the action. Sometimes you want a break in the action. You want to give the players a break. You can also do that by just changing those numbers at specific moments in the game. So individual enemies are great. An organized squad is better. It's hard to make fun and challenging gameplay with total randomness. It's kind of an important part of procedural generation. If you do not control it enough, the players just see it as total randomness, and that's not fun. It also creates for some unfair moments where I don't know, for some reason just spawned 100 of the hardest enemy in the game. Okay, cool, they're right next to you. That's an exaggeration. But it's an organized squad is better. You see this if you play any multiplayer game. Like if you're playing Overwatch with a bunch of random people, you're not gonna be as coordinated as the team of 6 that you're up against. So this is kind of where enemy chunks come in. If you're not sure what an enemy chunk is, it's kind of, you take a small bit of mechanics and push it together in a small chunk, and you can spawn just that chunk. So it's kind of an isolated obstacle that you can create in a small batch. Sometimes you want to challenge the player with these chunks. So like on the screen on the left, 4 birds are spawning on the corners, and that is just inherently more challenging than birds spawning randomly, because now they're coordinated and they're all attacking the center of the screen at the same time. Or sometimes you're not even trying to challenge the players, you just want them to like have a good combo moment. So you can set up a bunch of enemies that you take out in one flow and you feel really good about it. If you want to know more about chunks, I think the Spunky book by Derek Yu is one of the boss fight books. I think there's a whole chapter on how that game is chunked out in the levels, which is really fascinating. That game is not totally random. It's every part of the screen is a very specific challenge, and then there's an algorithm that ties it together. And then also, each chunk has a couple spots of randomness in it, where it's like, oh, this could be a pathway, this could be a ladder, this could be something. So it's like, it's pre-made obstacles with a little bit of change in them. And then when you combine them all together, the user just sees a completely random maze. But it's actually inherently designed well in the chunks. So if you want to know more about that, that's a really good resource as well. So how do chunks work with the system of costs and budgets? Basically, it ends up making it pretty easy. A chunk is the sum of its pieces. If you have a bunch of birds that cost 4, if you got the eyeballs that cost 1, you add it together. Something that we didn't account for when we first put this together was when you make an organized squad, they're harder. So the sum of its pieces is not 100% accurate. So we end up adding, at least what I called it in the code, a chunk tax, where if something is more organized and harder, you can actually nudge it up a little bit. Or if it's something that's like, oh, this is an easy combo, and it's easier because they're together, you can push it the other way. And that kind of allows you to edit that easily and coordinate it. Also, if you have the cost of the enemies, it makes scoring really easy. Because now you know generally how hard an enemy is. You can base your scoring off of that, and you have a point system. And then as you add, your points can be a mixture of the base cost of the enemy, plus the stats you're appending to it. And you have an easy way to calculate score. And then whatever other multipliers your game may have. And this is something that I think we're still toying with. So this hasn't been heavily tested, but because you know the score of the enemies and all that as you're spawning them, you can keep track of the total possible score you have offered the player. That doesn't mean they're hitting the score. They're probably, I would imagine, a low percent is ever actually hitting that score. But you can get kind of a measure of how well they're doing, which is cool. Because if you find out that, like, oh, the players are floating around at like 0.2 of their possible score, maybe you can tune the system to be a little easier for a little while. You can kind of adjust it to the player and how well they're doing. Or if they're doing really well, you can ramp it up a little harder. If you do try to do this, though, it is also important that you clear that number every so often, because if the users are playing for a long session, reaching that 1.0 score will just keep getting harder and harder and harder. So it's always good to have like maybe moments in the game where it's sectioned off, where it's like, okay, once you beat this section, we're going to clear that off, and you have a clean slate now. Because I don't know, maybe that level is way harder than the level before it, and you want to give them a fresh start. I think, like, I want to say Star Fox is a good example of this. Star Fox has a lot of like unlockable areas. I'm speaking of Star Fox 64, where you have to do something like basically flawless in this area, and you get a secret path. But that's only calculated in that one area. What you've done in other parts of the map are irrelevant. So I kind of like to think of, if you're doing something like that, section off in levels, kind of like that. So implementing into Unity, the way we kind of made it easy was to keep everything as generic as possible. We use scriptable objects for all the stats, and that allows us to kind of hot swap them between different enemies. If an enemy wants to share a stat, you can swap it. We have a move speed stat. So for some reason, for a certain wave, we don't want the enemies to move. We can give it a 0 move speed. That was easy. We don't have to code anything for that, because it's just using the built-in movement system. And then each wave is a prefab that's responsible for initializing itself and cleaning itself up. that allows you to, whatever order of events whatever order of events that happen to happen, they can just exist on their own. You can even layer them on top of each other. So as the game gets harder, maybe you want to spawn multiple chunks on top of each other. And they should clean themselves up properly, and that would make that feasible so you don't have this overarching manager that gets really complicated. So the way StarCrossed uses this too is we don't do 100% procedural generation. We have procedural generation happening. We have handcrafted chunks that are placed by the procedural generation system, but then we also want to have fully scripted moments where things are moving in a specific way, like it's very specific, enemies move in a pattern, as well as story sequences. So there's dialogue prompts that pop up. We want to be able to trigger that stuff within the same system without them colliding. And so by doing this, we have basically an event index that kind of iterates up. And as you get to a certain index, you check a list. Is something supposed to happen here? Do we have a very scripted thing we want to spawn? No? Okay, generate something, cool. And that allows us to easily plug and play the story moments within the system and kind of let the procedural generation sort of fill in the rest in a weird way. And that kind of allows you to expand and close those gaps of the procedural generation. Or you find out one area is like, oh, we want something more scripted here. Or you want something scripted with a little bit of randomness in it. You can do that too. Balancing. So you have all these numbers. Keeping all these numbers in one place allows you to kind of balance the game. And you can keep pushing these numbers back and forth. Maybe if a big story event happens, you specifically trigger certain numbers and put it back when it's done. So you can mess with kind of the budget per wave, the budget per enemy, which, like I said, that one's super important. That what changes like armies of weak enemies or a couple of strong enemies. You can change the enemy costs. Oh, this one enemy is showing up too much and it's becoming a challenge. Okay, they're more expensive now, so they stop showing up as much. The wave overlap times is very good for creating chaos. Controlled chaos, of course. And then also I would advise do not rely 100% on a formula. I think that's going to be really impossible to balance. You should tweak these live as certain gameplay events are happening. Debugging. Keep a spawn log while you're doing playtests in the background. Every time something spawns, keep a list of it. And then when something weird happens in the playtest session, you can refer to that and see like, okay, what happened here? Why did those pop up on the screen? You have a history of what spawned, what stats they spawned. That's super useful. A screenshot tool. We also built in a small thing that while it's playtesting, whenever a wave spawns, we take a screenshot of it. And then, obviously it's not a live production thing, this is for us in a controlled playtest thing, and it keeps it in a folder, and then when we go back and look through, we can actually iterate through the waves and see them visually, which is also cool. This is something I haven't done, but sounds really cool. If I'm keeping a log of it, and I'm already generating screenshots, can I actually make mock-ups from that log? If I have all the data, I should be able to make a mock-up. That's something I've been thinking about, which is really cool, that I haven't done yet. That's my screenshot tool. It's a really messy slide of just some screenshots. And something else I want to show is an example of kind of what this log actually looks like. So it's super messy. So this is, not only does it capture a log while they're playing, we can toggle that on and off. I also made it so you can do a simulation where you can say, okay, run 200 waves in a sequence and spit out what it's doing. And I found a lot of bugs this way. So this is a massive file of, I think I set this to 200 waves. And you can see like in a wave, you see, oh, it's spawning this enemy. It is spawning with these stats. It had a budget of this. It used this much of that budget, carried over a certain amount. I found a good amount of bugs this way when I was trying to work on stats bouncing between enemies and back out to new enemies. Also, I think the last time I made a build, I noticed that the eyeball swirly enemy was spawning a lot. And then when I made this, I saw there's 100 of them up here, which is really funny. So I can prove that that bug is real. I mean, you can play the game and see the bug. So that's also been very helpful when I saw bugs happening, but they weren't consistent. I couldn't always recreate them, so I did that to kind of reveal some more information for me. Okay. I'm not full screening that because I'm almost done. Screenshot tool, and yeah, that's kind of, so that's an overview of what we did with the enemy spawning in StarCrossed. Like I said, it's still a work in progress, but yeah, I wanted to share that. When we started working on the game, I was like researching like, how do you, like, what are your examples? Like, I don't know, like Geometry Wars came out forever ago, and I was like, how did they do it? And I look it up, I'm like, can't find anything. So I was looking for similar games like that, because it's kind of in line with what we're creating. And that was hard to find, so I figured it'd be helpful to kind of share what we did for StarCrossed. Yeah.
Well, thank you.
So I think I talked really fast, but I don't know, I have 3 minutes. If anyone has questions.
Did you look at how Left 4 Dead did it?
Left 4 Dead, I know they have like the intensity system, I forget what it's actually called, but it's like how angry the director is or something.
Yeah.
Yeah. I do like that system. That's a pretty well-documented system of you, like, oh, if the players are doing well, the director gets mad, and you make the director more mad. I think that's really funny.
I think Resident Evil 4 also had like a skill and difficulty.
Oh, I didn't know that. Ooh. Yeah.
So, I think that one facet of difficulty is how familiar the player is with the behavior of the enemies.
Right.
And in here, there's some behavior that's fixed per like enemy type, but then some of its characteristics that you're saying are kind of configurable.
Yeah.
Did you take into account at all how that affects difficulty, like the player expecting an enemy to attack with a certain firing rate, but then finding out that it's much faster or slower?
So we tried, that's kind of where the ranges help out. We never want them to be outrageous. We want to keep them in a container. So like, oh, if they see like, oh, this is what this enemy is possible of, then they can have some expectations. So I think that's about clamping the minimum and maximums to be a reasonable size. And if you want the bullet speeds to be super crazy where it throws the players off, have some sort of visual indication that something is different about this enemy. Whether it's like slightly modified texture or, just something, maybe like an angry emotion on them, I don't know, something visual that can alarm the player that something's about to happen. Yeah, cool, thank you.